continue our session of the thesis board, and we're going to we begin our panel session for the defense of the thesis by Omar Kotb. The thesis is submitted for the academic degree of the candidate of science in physics and mathematics, and under the order issued by St. Petersburg State University as of April 17th, 2020, 3190/1. Our session is organized in a remote manner under the order of St. Petersburg State University as of April 17th, 2020, 3190/1. I, Valery Kondratyev, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Nuclear Physics Research Methods of St. Petersburg State University, have been appointed the chairperson of this dissertation board. The order appointed the members of our board, and let me introduce them. First of all,
I declare the technical break finished. Let us continue our session of the Discussion Council. This is just the beginning, and let me introduce members of the Dissertation Council. Mitra Polski-Van Andreevich, Doctor of Physics and Mathematics, Professor of the Department of Nuclear Physical Methods of Research of St. Petersburg University. Can you see and can you hear us? Yes, I can see and hear you very well. Can see you. Next, Kostianenko Nina Anatolovna, Doctor of Physics and Mathematics, Professor of the Department of Molecular Biology and Polymer Physics of St. Petersburg University. Hopefully you can see and hear us. Yes, I can see and hear you. Good afternoon, colleagues. Ivanov Nikolai Arsenovich, Doctor of Physics and Mathematics, Associate Professor, Senior Researcher of St. Petersburg Institute of Nuclear Physics, National Research Center, Kotb Institute. Can you see? Can you hear us? Sanjevsky Andrei Alexeyevich, Doctor of Medical Sciences, Deputy Director for Scientific Work, Russian Scientific Center of Radiology and Surgical Technology, named after academician Granov, Ministry of Health of Russian Federation. Can you see? Can you hear us? And Vardinian Pagos Aganesi, Doctor of Biological Sciences, Professor, Head of Department of Biophysics of Yerevan State University, Armenia. Can you see? Can you hear us? Yes, the answer is positive. Yes, I'm glad. Council member, Horeshkov Vladimir Sergeyevich, Doctor of Technical Sciences, Professor, Institute of Theoretical Experimental Physics, named after Alekhanov of the National Research Center, Kotb Institute, is absent for a good reason. And the degree applicant, Kotb, Omar, Mahmoud, Elsayed. I can see you perfectly well. I can see you are smiling, ready for defense. Can you see? Can you hear us? Yes, I can see and hear you. Let us continue. Also, here we have the academic advisors of the degree applicant. Yezhov Viktor Fedorovich, candidate of Physics and Mathematics, Associate Professor, the Department of Nuclear Physical Research Methods at St. Petersburg University. And Paston Sofia Vladimirovna, candidate of Physics and Mathematics, Associate Professor, the Department of Molecular Biophysics and Polymer Physics of St. Petersburg University. You are online, right? Yes, the answer is positive. Well, the Dissertation Council is present. The degree applicant is online. We can all see and hear each other. So we may start our session. Let me repeat that our session, as you can see, is being held in the remote access mode. So we should all together watch the procedure in case there is a technical failure. Should inform me or the curator of today's defense and ask her to call a technical break to eliminate such technical issues. An important point, if the connection with me is lost, let Mitra Polski-Van Andreevich take over, hopefully. No one has any objections. Of course, we don't have any objections, but hopefully that will not happen. I shall also hope for that. Agreed. Well, let us continue. Let us continue. I have to inform you that our session is being recorded and broadcast online at St. Petersburg University website. And as you can see, the speeches are being simultaneously translated. We had some issues with that. And now the speeches shall be translated from Russian into English or from English into Russian. And you can actually switch to the language that you prefer. The applicant's page currently displays an email to which during the session all the listeners of the online session of the Dissertation Council want to send their opinions or ask questions to the degree applicant, but let me warn you that these questions should be related strictly to the presentation, and if they go beyond the scope of the report, they shall not be presented. Next, speaking of the regulatory documents, according with the order of awarding at St. Petersburg University, academic degrees of candidate of science approved by the local regulations of St. Petersburg University for a session of the Decision Council is considered competent if at least 2/3 of the appointed members of the Dissertation Council are present, but not less than 4 persons. Our Dissertation Council, as you can see, consists of 7 members. 6 are currently present. And that means that we have the quorum and we may start our session. The curator of today's session is an officer of the Department for Support of the Dissertation Council activity, Kotb, Natalia Vladimirovna, who shall draw up the attendance list in which all the Dissertation Council members present and their working mode shall be recorded. In this case, the remote mode. Before I give the floor to the degree applicant, we have to approve the procedure of today's session. Since we have the time limit of, and our session should not exceed 2 hours, and because of that, we suggest the following format, which we must approve. First, I shall talk about the documents submitted by the degree applicant. That will not take over 5 minutes. Then we shall hear the applicant's report. Please do not make it too long. You have only 20 minutes, but please do not exceed the limit by more than 2 or 3 minutes. Otherwise, I will have to interrupt you. Further, questions to the applicant strictly on his report, we will have to ask and hear answers of the applicant. I don't know exactly how long that will take. It depends on how many questions we have. But so it shall be, answer should take not more than 2 minutes. That will be followed by speeches of all the Dissertation Council in turn. And of course, these reviews shall include questions to the degree applicant to which he will have to give his answers. Next. Let us discuss how shall the degree applicant answer questions after each review is presented, or he will answer all the questions together in the end. Let Omar decide. I think probably Omar will answer questions after each review is presented. After that, we will have a discussion before open voting if we need it. A discussion of Omar's presentation and how satisfied we are with the answers, and then we shall proceed to open individual voting. I will have to count the votes and record them in the minutes of the meeting. Let me warn you that the decision on awarding or not awarding the academic degree shall be made in the course of the open voting. After that, the degree applicant shall be given the floor for his closing remarks, and hopefully that will not take more than 2 or 3 minutes. Does anyone have questions or maybe comments to this procedure? No, we think it's perfectly fine. Since the the procedure has been approved, with Ivan Andreevich, who gave his opinion openly, let us start running the procedure of the session. Well, now let me give the floor to one of the academic advisors of Omar, the candidate of physics and mathematics, Viktor Fedorovich, who will briefly introduce the degree applicant to us. Welcome, Viktor Fedorovich. Valery Petrovich made very good introduction. Omar Kotb during his time as a doctoral student at St. Petersburg University, Department of Nuclear Physical Research Methods, successfully passed all the necessary exams, presented, passed the candidates qualification tests successfully. He also defended his graduation qualification project. The theme of it is different from the theme of the thesis, as all the works were written at St. Petersburg University, and St. Petersburg Institute of Nuclear Physics, Kurchatov Institute. This is probably all I had to say. Thank you. On my behalf, I would like to add that the thesis by Omar has been accepted for defense by the order of the academic secretary of our university of the 14th of April 2020. order number 3062/1. And it's important that Omar wrote his thesis at St. Petersburg University and his academic advisors I have already introduced to you. He has 2 academic advisors because of the wide range of his study, number of publications. The degree applicant, which set out the main scientific results of his research according to the enclosed list, is 7. And we have to classify them since in peer-reviewed journals recommended by the Ministry of Education of Russian Federation, no, but in the journals indexed by scientific databases Web of Science and Scopus, 2 publications. The degree applicant submitted to the academic secretary of St. Petersburg University, to the academic secretary, a full set of documents to accept his thesis for consideration. All the documents submitted by the applicant, according to the information I received from the curator, comply with the requirements and are stored at the attestation file of the degree applicant, and copies are available from the officer of the Dissertation Council Activity Support Department, Natalia Vladimirovna Karpova, who is currently online and in touch with us and who can confirm my words. Before I give the floor to the degree applicant, I have to ask if I need to read all these documents, and or we shall not waste our time on this. We agree. There's no need to read the full list. Okay, then let us not be too formal, and let us proceed to the presentation. Omar, the floor is yours. The presentation shall be in English. Duration of the presentation should not be over 20 minutes. Please try to please download your presentation, Omar, so that all the members of the Dissertation Council could see it. Omar, can you hear us? Yes, please start. Please download your presentation and please start your report. Can you see? No, right now I cannot. I cannot see anything. Hold on a second. Can you see? Yes, we can. Can you all see the presentation? No, I cannot see, says the chairman. Shall we wait? I can see, and I'm quite far away from you all. I cannot see, unfortunately. Omar,
Просто я хочу переводить
please
на английском.
start the presentation. Start.
That's
I
just
can see
it.
the presentation. I cannot.
Hello?
Please call a short technical break. Let me call a technical break. You have 20 minutes.
Mhm.
Okay.
Hello.
Hello.
Now I'm showing my PhD presentation under the title of the effect of the high energy proton component of cosmic rays on the DNA structure. My name is Omar Kotb, scientific supervisor, candidate of physical mathematical science, Victor Fedorovich Yezhov, and a candidate of physico-mathematical science, Sofia Vladimirovna Baston. The aim of the work is to study the structure of a DNA molecule irradiated with protons with an energy of 1 giga-electron-volt in solutions, and compare the radiation effect of a proton and the standard gamma radiation, cobalt 60, as well as to study the effect of the antioxidant caffeine on the process of DNA damage by high-energy protons. The research objectives include development for a method for the irradiation and dosimetry of the biological samples on a proton beam of energy of 1 giga-electron-volt, simulation the effect of the proton component of cosmic rays on the genetic apparatus of the cells at the synchrotron 1000 milli-electron-volt of the St. Petersburg Institute of Nuclear Physics, testing the capabilities of various spectral methods to determine the structural damage in DNA irradiated with standard cobalt 60 gamma irradiation in aqueous solutions, studying the structural damage of DNA under the action of irradiation with the protons with an energy of 1 giga-electron-volt in solutions under varying conditions of irradiation, like ionic strengths of the solution, DNA concentration, and radiation dose, and comparing the radiation effect of proton and gamma radiation. Finally, obtaining the dependence of the radiation effect on the concentration of caffeine in solutions irradiated with proton and gamma radiation, and analyzing the effectiveness of the radioprotective action of caffeine. The importance of our study, the importance of studying the effect of high-energy protons on living matter is associated with space research, since cosmic radiation consists of 95% of high-energy protons. It is known that radiation damage to the body is determined by DNA damage of the most rapidly dividing cells. Therefore, the study of the defects in the DNA structure under the action of high-energy proton radiation is necessary for understanding the molecular mechanisms of the radiation effect, and to develop medical means for protecting astronauts. The relevance of these studies is also related with the improvement of proton therapy, which is one of the most promising methods of treating cancer. Secondly, a study of the biological effect of protons does not have such a long history as the study of the radiation effects of gamma radiation. The Petersburg Institute of Nuclear Physics has unique opportunities for conducting a wide range of biomedical studies of the effects of cosmic radiation and studies of the effectiveness of proton therapy. The statements to be defended as shown in the slide. The left figure shows the experimental spectrum of primary cosmic radiation as a function of energy. As shown in the figure, the most component of primary cosmic radiation is proton particles with percentage 95% as shown here, and 4% of cosmic radiation for helium nuclei, and 1% of cosmic radiation for other nuclei. The right curve shows the effective dose of the particle of different charges that make up cosmic radiation determined inside a spacecraft. As shown in this figure, it can be seen that the proton particles with atomic number equal 1 have the high contribution of the total effective dose. Under terrestrial conditions, we can high energy protons that can be produced by using accelerators. In our study, we use a synchrotron of high energy protons at the Petersburg Institute of Nuclear Physics. The relevance of such a beam is not limited to the radiobiological studies of cosmic rays, but also for the development of proton therapy. In this slide, it's shown the scheme of the medical proton tract of the synchrotron at the Petersburg Institute of Nuclear Physics. And the right upper figure shows the irradiation hall of the proton therapy complex. By using this technique, it is possible to deliver radiation dose from different angles, different beams, and this beam intersects in one point, as shown here, known as isocenter. This isocenter, this point located in the target, in the center of the target tumor. When the biological effect of ionizing radiation is deposited when the ionizing radiation is deposited in the biological structure, the DNA damage can occur directly or indirectly. Direct action can occur when the ionizing radiation interacts directly with the atoms, with the critical atoms of DNA and induce ionization and excitation, as shown here. While in direct action, the ionizing radiation interacts with other atoms or molecules than DNA, particularly water molecules, and producing reactive free radicals in a process known as water hydrolysis. The most reactive free radicals is known as OH radicals. The right figure shown here represent the DNA damage induced under the effect of ionizing radiation that can be divided into two groups. The first group is single site lesions like base damage, base modification, and single strand breaks. The second group is local multiple damage. That's, for example, double strand break and DNA cross-linking. In the material and the methods, in this work, we used DNA samples from calf seams with different molecular mass. All aqueous solutions were prepared using a deionized water. Sodium chloride, magnesium chloride, and bichloric acid were reagent gradient. Biflavonoid catechin was purchased from Sigma. In our work, it is proposed to use the spectral method for determining the total amount of DNA nitrogen bases to estimate the fraction of the destroyed nitrogen bases induced by ionizing radiation. The concentration of DNA in the solution was determined from the difference in the ultraviolet absorption spectrum, as shown from this equation, and by using the atom temperature, and by using the value of the calculated value of DNA concentration, we can measure the molar extension coefficient from this equation and hyperchromic effect. Both of them give us an information about the degree of the DNA helicity. We also measured the radiation chemical yield G that represented by number of modified molecules for each 100 electron volt of absorbed energy. The defects in the secondary structure of DNA can also be studied by using the melting method. When DNA solution is heated, hydrogen bond between complementary nitrogen bases are destroyed, and double-strand DNA is decomposed into two single strands. Using that method, the melting temperature is determined as the maximum point of the first derivative of the melting curve, and this is the temperature at which 50% of the DNA is denatured, as shown here from this curve. Firstly, we measured the ultraviolet absorption spectrum for native DNA at room temperature, as shown in this figure by black curve, and increasing the temperature step by step at fixed wavelength 260 nanometer to measure the melting curve, as shown in this figure, and consequently measure the spectrum for denatured DNA. And after that, cooling the DNA solutions to measure the ultraviolet spectrum for denatured DNA. Result and discussion. Our study in generally is divided into three parts. The first part is the application of the spectral method for determining the radiation damage in the DNA structure. The aim of this study is to compare the capabilities of the indicated types of DNA damage. Is to compare the capabilities of different spectral method to indicate the different DNA damage induced by ionizing radiation, and to study the effect of sodium and magnesium ions on the radiosensitivity of DNA in solutions. In general, radiation damage affects the ultraviolet absorption of DNA solutions in different ways. Firstly, decrease in the destruction of the nitrogen bases, decrease the intensity of the spectrum, while DNA denaturation induce hyperchromic effect represented by increase in the intensity. As shown in this figure, shows the ultraviolet, the upper curve shows the ultraviolet absorption spectra of DNA gamma irradiated in solution of different ionic strengths. We can observe that for low ionic strengths, the spectrum, the absorption intensity decreases with increasing the radiation dose, and this indicates that the affected factor is the destruction of nitrogen bases for low ionic strengths 5 millimolar sodium chloride. But for higher ionic strengths, 3.2 molar sodium chloride, we observed the two effects contribute to each other and cancel each other. To separate the contributions of these two factors, it is important to completely destroy the secondary structure of DNA, and in this case, only the base destruction factor, the base destruction only the affected factor can be observed. For all studied system, for low and higher ionic strengths, we observed decrease in the intensity with increasing the radiation dose. This figure, figure A, shows the dependence of the relative decrease in the number of nitrogen bases on the dose of gamma irradiation in solutions of different ionic strengths. We observed that a linear increase in the number of a decrease in the fraction of destructed nitrogen bases with increasing the radiation dose, while the slope of straight line decreases with increasing the ionic strengths. Also, radiation dose increase the denaturation of the DNA as shown in this figure B, while the higher ionic strengths increase the stability of DNA solutions. By using the calculated value of DNA concentrations, we measure the radiation chemical yield as represented in the figure C. We observed for low ionic strengths that radiation chemical yield decreases sharply for low ionic strengths in the range from 3 to 5 millimolar in lower in the range of lower dose from 0 to lower than 100 gray. We also measure a decrease in the radiation chemical yield in solution of higher ionic strengths with 15 and from 15 to 3.5 millimolar, although they have the same volume of the DNA. As we know, the volume of the DNA is decreased with the increase in the ionic strength, so we can assume that the dependence of radiation effect on the ionic strength is not affected not only by the volume of the DNA, but also affected by the DNA hydration. The defects in the secondary structure can also be studied by using melting method. By using this method, we measure the melting curve as shown in this figure. For all studied system, increasing the radiation dose decrease the melting temperature as shown here, and broadening the helix coil internalization interval. For low ionic strengths 5 millimolar, we cannot. It is not possible to measure the melting temperature. Obviously, due to the significant damage of DNA under these conditions. Although for higher ionic strengths at higher doses, 100 gray, we observed several maxima, and this can be assumed by can be explained by the formation of cross-linking. The second part of our study is to compare the effect of high energy protons and the gamma rays on the structure of DNA. As shown in figure 5, we measure the dose dependences of the relative decrease in the concentration of DNA nuclear bases under proton and the gamma radiation. As shown in this figure, the dashed lines are the data obtained in this work at higher doses. For all studied system, low and high electrolyte concentration, we observed that proton irradiation causes higher destruction in the nitrogen bases than gamma irradiation at the same dose. By using using the calculated value of DNA concentrations, we measure the radiation chemical yield as shown in figure 6. We also measure the melting temperature for DNA solutions irradiated with proton particles and observe that although increasing the radiation dose, decrease melting temperature, and observed a broadening of the helix coil transition interval. It is important to mention that it was possible to measure the melting temperature for the DNA solutions of low ionic strengths at higher dose 100 gray. We also measure the dose dependencies of the decrease in the melting temperature of the DNA exposed to irradiation with the protons and the gamma irradiation, and experiment showed that proton particles induce lower drop on the DNA melting temperature than gamma irradiation for solutions of ionic strengths 0.5 molar sodium chloride, for all studied doses, and for lower ionic strength 5 millimolar for in the range of doses from 70 to 100 gray. In order to investigate the contribution of the direct and indirect action of ionizing radiation, we also measure the dependence of the radiation chemical yield of the destroyed bases on the concentration of DNA in the radiated solution under proton and gamma irradiation for different gamma irradiation at a dose of fixed dose 50 gray and fixed ionic strength 5 millimolar. The right figure B shows the initial progress of the dependency. For gamma irradiated solutions, we observed a plateau in the range of concentration from 18 to 70 times 10 minus 4. This effect due to represent that the affected factor is the indirect action of radiation that is affected only by the amount of radicals, and it is constant for the same dose. We also measure the dependence of the melting temperature on DNA irradiated by proton and gamma radiation, and shown in figure 10. As the radiation dose decreases, we observed increase in the melting temperature in solutions irradiated with gamma, and even reaches the characteristic value of irradiated with protons, and even reaches the characteristic value of native melting temperature of DNA. On the otherwise, the melting temperature of solutions irradiated with gamma decreases sharply with decrease in the concentration of DNA. And for ionic strength higher than 0.01 gram for deciliter, we observed a saturation on the melting temperature. We also studied the destruction of the radiation damage induced in the thymidine nucleotide in solutions under effect of proton and gamma radiation. We observed that proton induce higher defects in solutions than gamma irradiation, and in the solutions of thymidine. And in the presence of ethanol, the damage in protons lower than damage in under the effect of gamma radiation. So the protective effect of ethanol is higher for gamma irradiation. The last part of our study is to study the effect of caffeine in the process of DNA damage by high energy protons and gamma radiation. Caffeine belongs to the group of bioflavonoid polyphenols of plant origin and characterized by the ability to easily oxidize. The hydroxyl group of caffeine are hydrogen donors, and therefore it is able to inactivate free radicals. The search formula of caffeine as shown in this figure. We also measure the dependence of the melting temperature of DNA on the concentration of caffeine in irradiated solution, in unirradiated solutions as shown by a green curve, and in solution irradiated with protons, red curve, and gamma yellow black curve. In the presence of caffeine, we observed that the melting temperature does not change with increasing the concentration, and this is agreed with the literature data that assume that the caffeine binds weakly with the DNA solutions. With increasing the caffeine concentrations from 0 to 5 times 10 minus 5, we observed sharply increase in the melting temperature for both protons and gamma irradiation. But we observed that melting temperature in solution irradiated with gamma even reaches the characteristic value of the DNA solutions. Main results and conclusion: a decrease in the radiation effect with an increase in the ionic strength. Mu of the irradiated solution was detected at gamma irradiation doses up to 100 gray, which can be explained by a decrease in the size of the target and also by the change in the structure and the composition of the DNA hydration shell. For the first time, the G value of the destroyed nitrogen bases of DNA were obtained, as well as the melting temperature and the parameters of the secondary structure of DNA in solutions irradiated with protons with an energy of 1 giga-electron-volt in the absorbed dose range from 0 to 100 gray, with varying electrolyte concentration and DNA concentration. It was found that the yield of the destroyed nitrogen bases of DNA and thymidine nucleoside in solution under the action of proton radiation is higher than that of cobalt-60 gamma irradiation. The dependence of G on the concentration of targets obtained in this work and the experiment using scavenger of OH radicals, ethanol, show that the contribution of the direct action of radiation on DNA and thymidine in aqueous medium is higher in the case of proton radiation than in the case of gamma radiation. The dose dependencies of the melting temperature, Tm of DNA irradiated with higher energy protons and gamma quanta at different ionic strengths, 5 and 0.15 molar, were measured. A monotonic decrease in melting temperature with increasing radiation dose was found, as well as a broadening of the temperature interval of helix coil transition, indicating an increase in the heterogeneity of DNA structure. At dose of 100 gray, signs of the formation of inter-strand crosslinks are observed. The effect of well-known antioxidant catechin on the radiation damage to DNA was studied using the melting temperature as a criterion for radiosensitivity. The dependence of melting temperature on the concentration of catechin in the irradiated solution were obtained. It was found that at catechin concentration above 2.2 times 10⁻⁴ molar, the melting temperature of gamma irradiated DNA almost completely keep the value obtained for native DNA. While melting temperature of DNA irradiated with protons, an energy of 1 giga electron volt is 0.85 of the melting temperature of native DNA. This confirms the conclusion made in the work about the greater contribution of the direct action of radiation of DNA damage during proton irradiation. The results show that the traditional protectors, scavengers of free radicals, which are used to protect against photon radiation, will be less effective in protecting the body from damage by high energy protons. Scientific novelty of the results: firstly, a method of irradiation and dosimeter of biological samples on 1 giga electron volt proton beam has been developed. Modeling of the effect of the proton component of cosmic rays on the genetic abilities of cell on the cyclotron 1000 milli-electron volt of the St. Petersburg Institute of Nuclear Physics was carried out. The SPRIN method was used to determine the radiation damage of DNA bases for the first time. For the first time, those dependencies of the radiation chemical yield G of the destroyed DNA nitrogen bases under the action of protons with an energy of 1 giga electron volt were obtained. For the first time, the dependence of G on the destruction of bases on the concentration of DNA in solutions during proton irradiation was determined. For the first time, those dependencies of the melting temperature of DNA irradiated with high energy protons were obtained. Finally, the effect of catechin on radiation damage to DNA under the effect of protons with an energy of 1 giga electron volt was studied also for the first time. The practical significance of the work lies in the fact that the obtained data can be used to determine the relative biological efficiency of high energy protons, and also to calculate the radiation load on the cosmonaut's body, and also to evaluate the effectiveness of proton therapy. The result of experiments using the catechin antioxidant will be provide recommendations for choosing the medical protection of the space crew from the interference of cosmic rays. The research results were published in reviewed journals, 2 published papers, and the cell paper under review in Journal of Biophysics. And also the work were reported in the at the following scientific conference, same conference. Thank you for attention.
Which was a very good presentation. Let us start our discussion. Please, I invite members of the Dissertation Council to ask questions regarding the presentation made by Omar. I don't have any questions. May I ask a question? Can you hear me? Nina Antonovna. Omar, I would like to ask you, you compared 2 types of proton, high energy protons and gamma radiation. My question is, from the point of this DNA destruction, is there any difference in these 2 types of impact radiation? You concluded that protons cause a more direct effect than gamma radiation. From the point of destruction of bases, is there any difference between the effects caused by these 2 factors?
Yes, there is difference. These 2 types of radiation, protons, particles, and the gamma radiations, both of them contribute the difference in the direct and indirect action of radiation. where in the indirect action of radiation, the damage induced for all DNA molecules with the same probability. But in the case of indirect action of radiation, free radicals interacts differently with the different group of DNA in different ways. Therefore, gamma irradiation is most probably for indirect action, while proton irradiation is most probably for direct action. Thank you.
Thank you for your answer. More questions, please? I have two questions. A continuation of the previous question. How can you explain different mechanisms of DNK destruction with the same values of energy loss of protons and gap? And
we used different we used two types of radiation. Gamma radiation, as we know, have the linear energy transfer 0.3 kiloelectron volt for each micrometer, and also we calculated and known that the linear energy transfer of high energy protons 1 gigaelectron volt has the same linear energy transfer. But the defects in the secondary we measured the melting temperature, and we observed the destruction of nitrogen bases of protons higher than gamma irradiation, while the denaturation for both them is the same. Why the destruction of nitrogen bases higher for protons than for gamma irradiation, but they induce the same DNA denaturation, and also there is difference in the melting temperature. This can be explained that there is the melting temperature is determined from the average damage in the DNA structure, in the primary and secondary structure of the DNA, and is determined from the is affected by the composition of the particle track and the distribution of ionizations in the beam path, and particle track and distribution of ionization is different for protons and gamma radiation. They have the same linear energy transfer, but they have different particle track and different distribution of ionizations. Вы меня слышите? Ага. Угу. 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 No, many. We don't study the change in the dose rate in our study. Hello? Mm-hmm.
Thank you. Okay, more questions. I have a question, please. Welcome. Thank you. I would like to clarify still by which mechanism caffeine is bonded with DNA, because in your thesis, your reference number 192, author Chan Pai, published in 2019. So the bonding mechanism is 2.7, but we know, as it is known, if through small curve ligands are bonded, the bonding constant is approximately 10 in the 6th degree to 10 in the 8th degree, and electrostatic mechanism of bonding is approximately 10 in the 2nd or 3rd degree and is weak. With which bonding mechanism did you compare your, which mechanism is that? I mean, absorption, intercalation, external bonding. I'm talking about catechism. What is your opinion? Because your situation is unusual. There are breaks. This is not a native structure. Catechin. Is it externally? Is it bonded externally? You ask about your questions about interaction between catechin and DNA. Which mechanism? I want your opinion. You have worked with this material for enough. I am an expert on DNA ligand interaction. So I'm interested in your opinion. So you did not ask. Sorry. So your question is about interaction between catechin and DNA. How do they interact? Intercalation or absorption? I have, let me clarify, does it interact with any? Yes, it's, does it,
Да, относиться с ДНК и работает как
with DNA, and it acts as scavenger. Maybe. This could be. Thank you. Do we have more questions? Yes, I have a question, please. Sanjevsky, Andrei Alexeyevich. Have you compared interaction of catechin with other radio protectors currently used for protection from proton radiation? We used ethanol. And we observed that ethanol is a more efficient scavenger in solutions under the effect of gamma radiation, higher than the gamma radiation. Did you hear me? So we used ethanol as a scavenger. Andrei Alexeyevich, are you satisfied? Yes. More questions? Do we have more questions, please? Omar, I have a question. In your research, you used water solutions with different concentration. Why high ion power leads to less destruction of DNA? So what are the protection mechanisms, you think? I understand why we used higher concentration of ion power, solutions with higher ion. So I see that higher ion power inside human body. We used such high doses to learn more about the destruction, how the destruction is related to ion power. Because in the beginning, when we determined destructions, when we registered destruction, we noticed. I can show you a picture. Can I? You can just tell me. I know which slide you mean. Okay, so just tell me. When we increased ion power at low ion power, we noticed that destruction damage decreases as the dose grows. And yes, we know and when with increasing the power, the destruction increases because DNA volume. Valery Petrovich, we cannot see Pagosta Ganesevich. No, I'm here. Thank you. I can see Pagosta Ganesevich. No, Pagosta Ganesevich is here. So we will not take a technical break. So please continue, Omar. So when we increase the ion power, we saw that we registered DNA destruction because when the is increased, DNA volume is decreased by 2 times. That is why this damage so ion power depends on amount of DNA. So we increased the power to learn more. When we increased to the power to 3.2, we also increased. We also saw less damage. So we suggested that damage depends on the power, not only on DNA volume, but also on DNA relationship. So we use such high power to learn more about the process and the relation. I understand. Though from the biological point, such solutions are destructive for living organisms in themselves. Maybe. But from the scientific point, it is interesting. In model, in experiments, it is interesting. Okay, more questions? Do we have more questions to Omar? I think so. We have asked enough questions. Then let us continue our session, and following the official procedure, we have to hear the reviews of the members of the Dissertation Council. Let's call it technical break. For how long? Please continue. 15. So we can continue, right? So we shall proceed to the hearing the reviews of the members of the Dissertation Council, and I suggest when presenting your reviews, please focus only on the key points and maybe critical remarks that you have to save time. Let me start because we have some external reviews submitted by Timkovsky, Andrei Leonidovich, Doctor of Physics and Mathematics, Senior Researcher, Head of Laboratory of Biopolymers of Department of Molecular Radiation Biophysics of St. Petersburg Institute of Nuclear Physics. And I have to read this review to you. I looked through this review. The key points I will read. The thesis by Omar Kotb is dedicated to a highly relevant issue of safety of manned space flights, because most harmful for human component of space rays are high energy protons. The nucleus is studied consequences of radiation in the water solution by proton beam with energy of 1 GeV on synchrocyclotron. The reviewer claims that the structure of the thesis is traditional. The author clearly states provisions submitted for defense, outlines scientific novelty, results and practical significance of the work are very important for developing protection participants of manned space flights, astronauts, and can also be used in the proton therapy. Further, the reviewer says the list of literature includes 194 references, most the works published in the past decade. So the review demonstrates good knowledge of the subject. Further, the review discusses the experimental part of the work. As I understand, this is the last chapter of Omar's thesis, which summarizes the results of proton radiation on DNA structure and compares it to the effect of gamma radiation. In the work, spectral studies of model water DNA solutions radiated with high energy protons in wide range of doses and ion force, as we saw in the applicant's report. As a result, the author identified relations, decreases radiation damage of DNA. The author emphasizes that an important result is that the protection mechanism of catechin is less efficient in case of proton radiation rather than after gamma radiation. Then there are some critical remarks. One is connected with this chapter, according to the author. When describing known methods of DNA research would be appropriate in this, should be given in this chapter, should be presented in the chapter dedicated to literature overview. Further, the author claims that the thesis has very few mistakes or misprints, and that is why there's a stupid mistake which he found, and we all noticed it, and he is quoting this page where this misprint occurs on synchrocyclotron. Was created only in Russia, source of repeating the spectrum of atmospheric neutrons. So this mistake also occurs not only in the Russian, but also, as you know, the thesis was presented in 2 languages. So this stupid mistake by no means affects the overall high quality of the work. And provisions submitted for defense have been proved. The content of the work was presented in 2 articles. And further, the author concludes that the degree applicant deserves to be awarded the degree of candidate of physics and mathematics. Dear Omar, please answer critical remarks. First of all, I would like to thank Andrei Leonidovich Timakovsky for his comments. I agree, and I will certainly take them into. So please try to avoid these mistakes. As for neutrons and protons, this is not a mistake. In uranium target, 20 by 1 proton, and maybe I should have in my thesis more clearly explained that here we're talking about the secondary radiation. Yes, of course, if you explained this, that would be okay. Okay, thank you, Omar, for your answers. The next review is review by Mitropolsky. Thank you. I will not read the whole review. I don't think this is necessary. Just as my colleagues, I believe in the relevance of this work, scientific novelty of results obtained by the author, and 5 points all include the word for the first time, first measured, first determined. So all this is very good. Practical value of the work is obvious, is absolutely obvious. Experimental results can be used for medical protection of astronauts and for patients undergoing proton therapy. But I have some critical remarks, and here they are. This is first. I have a question regarding the title of the work. As so one the high energy protons, 1 GeV protons is the, because space protons, GeV protons are the most intense part because then they reduce dramatically. So we understand what the author means, but I think the title is not good. So this is my first comment. I don't think that something needs to be changed. Also, there is a table in 1.2 which demonstrates linear energy transfer and biological efficiency of radiation, and it mentions neutrons. The with neutron source has just been discussed. Obviously, when planning the work, the author probably wanted to study neutron radiation on biological objects. That is why the neutron source was, and neutrons were inserted, but neutrons have a different mechanism of ionization, and they are initially neutral. They don't cause ionization. So in my opinion, in the context in the context of the thesis, mentioning neutrons is not necessary. That is why I thought it distracts, because the figures look strange and they distract attention. And so it would be good to see a more detailed description of the experimental unit and of equipment used for monitoring the proton beam, because these were the major measurement devices, and their description are very interesting to any professional. So these are my 3 comments. Yet they do not affect the positive assessment. I enjoyed reading the thesis. I read it twice, and I think that the degree applicant deserves to be awarded the degree of. It's a good scientific work, and I'm very glad that Omar is. So that's all that's all I wanted to say. Thank you, Ivan Andreevich. Omar, would you like to answer? First of all, thank you, Ivan Andreevich. Thank you. And as for your comment, first comment, of course, I agree with your first comment. The title, the energy is quite small, of space radiation is quite small. And the second comment about neutrons in the table, yes, of course, I agree. And I shall take it into account in the future. As for more description of experimental unit, in chapter 2, titled Radiation and the Symmetry of 1 GeV and gamma quants, I agree. Thank you for your comments, and thank you for your kind words. Thank you, Omar, for your answers. Next review shall be presented by Ivanov Nikolai Alexeyevich. Welcome, Nikolai Arsenyevich. I will not repeat what has already been said about the relevance and significance of the scientific results. The practical value, in my opinion, is high, not only for space flights and proton therapy, but for our space station, where astronauts spend months. And I think the author of the work could actually conduct some experiments at the orbital station, taking samples putting samples inside the orbital station. Among the scientific results, I'd like to focus on 2. The first result is the author compared protons and gamma quantum, and as a result registered new aspects of interaction. This relates to direct mechanism of DNA destruction, and that the traditional radio protectors, unfortunately, cannot be used with protons. So the result is highly relevant. Now, I have 2 critical remarks. First, as I have already, it's well known that efficiency of radiation impact depends not only on efficiency. So you get your 100 grays on an accelerator in approximately 1 minute. In space, such amount is accumulated over months. And unfortunately, there is that space flight takes at least a flight to Mars would take at least 6 months. In the thesis, I saw no reflections on this, how the impact will change at different doses and dose power. I did not see any assumptions in measuring the radiation dose of protons and gamma quantum. The error should be quite small, approximately 10%. So the efficiency of protons and gamma depends on measurement error. And third question is maybe not to the author, but of course, in good old times, such theses were submitted in 2 academic specialties. Maybe I should not use subjunctive mood here. Thank you. Thank you very much. Thank you, Nikolai Arsentovich. Please answer. Thank you very much, Nikolai Arsentovich. So the first about the dosage power, so I could not find any data on the impact on radiation effect. Will be very glad if you could recommend any such works to me on dose power to me. So I used high power in my work due to limited time. Could use the proton beam, but I could suggest that increasing those output ionization density would increase. So the possibility of free radicals will enter the biological target, and further the relative biological efficiency will be reduced. We know that with increasing output, biological efficiency is reduced, maybe for the same reason use such dose. And the second comment, error, the error, measurement error, depends on measurement error is insignificant, and the error of, so that is the main contribution is plus minus 3 gray, and the error is 2 gray. And the last your last comment is the work, my research, but as since my took the doctoral course at the Department of Nuclear Research Methods and used nuclear physical laboratory. So that's why this academic specialty was, such as nuclear physics, was chosen. Thank you. Thank you very much. Thank you. Next, let me give the floor to Nina Anatolyevna Kasyanenko. Thank you, Valery Petrovich. Me, as the previous speakers, I will not read the entire review because it has been available at university website. I would like to complement relevance, practical significance, and undoubted novelty, especially in the sphere of comparing two radiations. And here we may make conclusions on the biological effect of these factors have on human body. The thesis is written in a traditional manner, as was mentioned by Dr. Timkovsky. The first part is dedicated to literature overview, and the author has reviewed in detail all the aspects of the points necessary for the reader to understand what is the subject theme of the thesis, which approaches the author uses, what has been done. So it gives an impression that the author has good understanding of the subject, knows the literature well, and set himself good tasks and objectives, which he managed to fully achieve in this work. What I also wanted to mention the part on the study methods is spectral methods. Maybe it would be good to use a wider range of methods, but because of novelty, because such the data is very scarce, but very carefully. The method, all the studied damage, types of damage that can be registered, and their DNA melting. And we should the use of spearing method, spectral study, and make conclusion on destruction of nitrogenous base. So I think this is a full gives a good full overview of how the tasks set have been solved. As for the main results, I'd like to emphasize that in the fifth chapter, which contains the results and results, here the author obtained interesting new data, and especially I'd like to mention second part of chapter 5, where the author compares the impact of radiation and concludes that the impact of direct impact is great in the case of protons, and makes conclusions that how it's possible to view protectors used for gamma radiation from the point of protein radiation. So this data is very interesting. Of course, they set new questions, and we would like the author to continue these studies. Some interesting data that are of certain interest. From the speaking of critical remarks, of course, the thesis is on the junction of two subjects, is impact on DNA molecule. So here are my comments. I will read them. Let me read them. When analyzing gamma treated DNA, the author gives relation of a relative change of DNA absorption, the broad 260 nanometers. From spectrum given in figure 3.1, we see that to get the GALCA from registered in the band of absorption with maximum 260 nanometers, radiation with increases with wavelength under 238 nanometers, while radiation of same hydrolyzed solutions can be seen only with absorption in the entire range. From chromophores, obviously because of dispersion. How can the author explain these results? Did he look at radiation spectra of previously hydrolyzed solutions? The second question, how can you explain the system of relation of radiation chemical yield of damaged nitrogenous bases on radiation dose in 0.15 which changes in DNA shell determine a reduction of the radiation effect with growing concentration. Next comment, since iron power of solution plays an important role in DNA destruction, maybe the author should have looked the role of oxygen atoms of and the work has contains unsuccessful phrases which affect the meaning, the significance. Use the spearing method used for measuring DNA concentration. It would be better to use, but these remarks maybe are not critical. And I would like to say that in general, the work is written, the work is very interesting. I watched Omar at work, and I always was always impressed by his desire to get more results, and he was very active. And so maybe he did not do everything he wanted, but the data that he obtained obviously is very interesting. And I have no doubt that Omar deserves to be awarded the degree, and the work complies with all the applicable regulations. Thank you, colleagues. Thank you, Nina Anatolyevna. Omar, can you please thank you, Nina Anatolyevna. As for your first, regarding your first comment, when analyzing this was a region of wavelength less than 200, we can assume that increase in absorption is caused by changes in the spectra of nitrogen bases after their destruction and modification under irradiation. However, this hypothesis requires confirmation. Small additional scattering is likely to occur in non-hydrolyzed and hydrolyzed solutions. It can be caused by the appearance of aggregates, for example, due to cross-linking. And irradiation of hydrolyzed solutions was not performed. So that would be an interesting experiment, and which we would like to do conduct in the future. And as for your second remark about the iron power is 0.5 natric available data is not enough to answer. We don't have enough data to answer this question. So we need to conduct another study. As for the third question about the changes in the hydrogen coat shell, in the authors 119.168 note that the structure of DNA hydrate shell affects the radiation effect for at least two reasons. Due, as I explained, due to the changes in the secondary structure of the DNA and due to the changes in the number of water molecules associated with the DNA and then part of the target. In our experiments, the secondary structure of the DNA corresponds to the B form, changing in the size of the target, changes the ratio between direct and indirect effects of radiation. In addition, there is a difference in the composition of radiolysis of bound water and bulk water. Finally, the greater the concentration of the ions, the less the charge of DNA, and therefore is less interaction with charge and polar products of water radiolysis. We may also assume that natrium ions located in the immediate environment of DNA have some shielding effect for ionizing radiation. And regarding your fourth comment, yes, I agree, and maybe I will do that in the future. And the last comment I also accept, of course, and I shall take it into consideration in the future. Thank you. Okay. Are you satisfied with the answers? Yes, I'm fully satisfied. Thank you. Thank you very much. Then let us proceed to the review by Stanjevsky Andrei Alexeyevich. Welcome. Andrei Alexeyevich, can you hear us? Yes, can you hear me? Yes, now we can hear you. Dear colleagues, I will not only focus on the medical issues, maybe, since the work indeed is interdisciplinary, and it lies at the junction of biology and medicine. The work has been performed on a unique equipment, which, despite that, has a medical channel, and our center had the opportunity to work with patients on this unit, but before we used the for proton therapy, and in this work that we are discussing now, the author obtained data which can be used to determine relative biological efficiency of proton with energy of 1000 MeV, and this data from the practical point can be used to study and to assess efficiency of proton therapy with such high energy. So this is one point I wanted to mention. And second, one of the components of the work is the study of radio protection effect of catechen used with proton irradiation. And in my opinion, this work for medicine is relevant because in medical studies, I never came across any works dedicated to the study of radio protectors in proton therapy. I would like the author in the future, hopefully, to pay attention to a wider range of studies of catechen with wide range of radio protectors which exist today, which are known today, but hopefully that will happen in the future. I don't have any major comments, and I think that the author deserves to be awarded the degree, and the thesis is a complete scientific study. Thank you for your attention. Thank you, Andrei Alexeyevich. Thank you. Omar, what will be your answers? I want to thank Andrei Alexeyevich for your review and for your comments. Thank you. Okay, now we shall give the floor to Vardavanyan Pogos Aganesevich. Well, considering we've been discussing for nearly 2 hours, I will be very brief and I will not take too much of your time. I just want to start with a small comment. The words of Nikolai Arsentyevich. Can you hear me, right, Nikolai Arsentyevich? You can see me, hear me? That earlier such works were presented in 2 academic specialties, but to me as a physicist, it's a pleasure. And during these 2 hours, I've been enjoying myself because my biological methods, spectral methods, seem to be very instrumental to address the task set by Kotb. And in connection with this, maybe I'm a little bit immodest because I am a biologist by my biology major. Biophysics is still physics, and in this respect, one specialty code is enough, and physics came very instrumental in this work. And so I'm very pleased to Secondly, I'd like to go back to my main question regarding the mechanism of bonding or non-bonding, as is a very interesting idea expressed by Nina Anatolievna. So maybe this happens indirectly because at some point we studied laminoids, and is there any interaction and what it is, but not in this light. And we managed to demonstrate not to, but here the situation is absolutely different. Here, gamma radiation, proton radiation, maybe there is something connected with intercalation of the molecule, DNA molecule. I don't want to take too much of your attention. I'm very satisfied with the speech of the doctoral student, and your Russian is as good as your English, and you could have easily presented your thesis to us in Russian. So I think the thesis made a very good impression on me, as written on a high level. Results are credible and may become the basis for further research, and the degree applicant deserves to be awarded the academic degree, and I shall vote in favor of this thesis. Thank you. Thank you, Pogos Aganesovich. Omar would like to thank you very much if you have anything to say. Thank you, Pogos Aganesovich. I'm very pleased with your comment regarding the Russian language, and thank you for your comments, for your review. I'm very grateful for. Thank you. Okay, thank you. Now, according to our procedure, I have to read I have to read the review by Harashkov Vladimir Sergeyevich, who is absent for a good reason. Let me see. I will try to read only some points. The thesis lies on a link of nuclear physics and medicine, as we have already discussed. And the task of the thesis is the study of space radiation on astronauts during long missions. For modeling, is in the author chose synchronous cyclotron with proton beam energy of 1000 MeV. So the choice of biological impact of proton radiation of such energies is very important to justify the effectiveness and improved methods of proton therapy. And maybe one of the main and most dangerous radiation damages to the body is damage to the DNA structure, which is the carrier of genetic information. Therefore, it's quite reasonable that as biological objects, the author used water solutions of DNA to study structural, is used both standard methods, this was already mentioned by Nina Anatolievna, and to measure the radiation yield of destroyed bases. The author, for the first time, applied the method of spearing, which we have also mentioned today. Further, is for the application of results, and agreement with data obtained for gamma relation with available data, which prove reliability of obtained data. And as for the practical significance of the work, here the reviewer, I should not repeat, speaking of critical remarks which do not affect the overall, is short description of method of measurement when conducting the irradiation or proton breed. And the conclusion is that the author deserves to be awarded the degree of candidate of physics and mathematics. And if there are any questions, probably no. I think Omar can say something to this. Thank you for the comments, Vladimir Sergeyevich, and for the review. I agree, of course, with the comments, and I shall take them into account in the future. Okay. So we read all the reviews except for my review, and not to waste time, I will briefly summarize what was already mentioned today. We heard many reviews, different opinions of the members of the dissertation council, though which consists of respected, distinguished scientists, as we know. As for me personally, to me, the value of this work is in the fact that it studies the possibilities of radiation protection from the range of energy, as proton energy, and whether we want it or not, human life today is closely connected with ionizing radiation. So we suffer on the Earth from its effects because we have many objects of nuclear industry, and on space stations we have to protect astronauts working there. And what is valuable is that the thesis by Omar studies not only those that damage under the influence of high energy protons, but also this is in connection with this high, let's call them high energy, but the author, it's important for me that the author studied the impact of caffeine on DNA destruction, and for me this manifests relevance of the work. And what else do I want to say? That the practical significance of studies, but that has already been mentioned by my colleagues, and I can only join what has already been said. As for critical comments, speaking of physics, I don't have any comments regarding the physics part, though of course I agree with what was said by Ivan Andreevich and by the previous reviewer, that for a specialist on nuclear physics, it would be good to explain more the methodology on proton beam, which unfortunately is very short in the thesis because, as we discussed, this thesis lies on the link of nuclear physics and biophysics, with the emphasis on biophysics. And Nina Anatolovna has demonstrated that these studies by Omar are relevant and have practical significance. And on my side, I think that the thesis is a complete scientific study that contains solutions to a relevant scientific problem on the impact of irradiation, and the content of the work fully complies with the requirements. And that is why my conclusion is similar to conclusions made by other members of the Dissertation Council. Omar deserves to be awarded the degree of candidate of physics and mathematics, though there is biology and medicine in his work, but in the definition of the degree is physics and mathematics. However strange then, if we all, because according to the in the second part, the main comment, I have already asked my question and I got a good answer, so I will not repeat my question. That is why we have to thank you for according to our procedure. Thank you, Omar. For according to the procedure, we have to hear to the speeches of the academic advisors. We have 2 academic advisors. Already we've exceeded the time limit, but because the work is so interesting and got it, and it caused so much discussion, I think we are okay with exceeding the time limit. So let me give the floor to Viktor Fedorovich and Sofia Vladimirovna, and let them briefly tell us about the work and about the practical work of Omar under your guidance. Viktor Fedorovich, please start. Okay. I would like to say, first of all, how purposeful Omar demonstrated when he was enrolled in the doctoral course. He had 2 tasks. He wanted that after returning to Egypt, he could work as a scientist and as medical work. So he tried to achieve these both goals. You've heard how successful he was as a scientist. Also, I'd like to say that the theme of his thesis, he found by himself. He contacted biologists, and being a doctoral student of the Department of Nuclear Physical Research Methods, he found biologists who were interested in the theme, and so he achieved his results. As for medical work, he wanted to work in the sphere of nuclear physics, so he took an internship in Dubna, and radiation therapy and proton therapy he studied there, which is a medical channel. It's St. Petersburg Institute of Nuclear Physics, and he studied this method well also. So all his goals, all the goals that he set himself, he achieved very well. And also, I'd like to mention his broad theoretical basis. He was able to understand new spheres of physics and biology. He read many books and described this in the thesis, and he has demonstrated good experimental skills, both in the sphere of nuclear physics and also in the sphere of biological studies. And that is what I wanted to say. His purposeful, how goal-oriented he is. Thank you, Viktor Fedorovich. Sofia Vladimirovna, could you please say thank you, dear colleagues? I, just like Viktor Fedorovich, would like to say that Omar is very active. He's a very active man, very interested. He always strives to broaden his activities, his knowledge. He found our laboratory from the, so we are not biologists maybe, but we are physicists. And so we are, our specialty is physics. That is why, so we, there is this connection between our fields. So Omar found our laboratory by himself, and he himself formulated his task, which he managed to achieve in the thesis that has just been presented to you. I'd like to mention, in addition to all the positive points mentioned by Viktor Fedorovich, how hardworking Omar is. He obtained lots of experimental data, which he managed to analyze, and so they became the basis of his thesis. In addition to that, he was an active participant in various scientific conferences. He took part in the winter school of Institute of Physics. I don't remember exactly how many times. And in other conferences, he made presentations, spoken presentation, oral presentations at conferences which in nuclear physics and in biological, biophysical studies. So he tested his results at various on various platforms, and I'm very grateful to Omar for finding us and for writing such an interdisciplinary work, because he introduced me to my colleagues from the Department of Nuclear Physical Methods of Research. Though we worked in the same faculty, we met because of Omar and achieved interesting results together. And hopefully, even after Omar goes back to Egypt, we shall continue our cooperation, and hopefully that will bring good fruit. So we will always remember Omar, and we'll always speak well of him. Thank you very much. Thank you for your attention. Thank you very much, Sofia Vladimirovna. The reviews of the council members and of academic advisors have been presented. So let us proceed to the final part of our session. Dear colleagues, I think we don't need any technical break, to discuss the results before we vote. I think we have discussed everything during over 2 hours, and we are ready to vote now. Members of the Dissertation Council, are you okay with that? Yes, we are. That's excellent. Then let me put forward the question of awarding to Omar as academic degree of candidate of physics and mathematics in nuclear physics to open individual vote. Here we have a reminder that a decision of the Dissertation Council on awarding the scientific degree is considered positive if more than a half, but not less than 3 members of the Dissertation Council vote for it. So this is for us to, this reminder informs us what we should keep in mind. So let us vote, and I will ask each council member individually. And Ivan Andreevich, what is your opinion? Are you for? I am for awarding the degree of candidate of physics and mathematics. I see. Nina Anatolovna, what is your opinion? Nina Anatolovna, I'm for awarding the degree. Is it necessary to put my hand up? No, it's enough to just to say I'm for awarding the degree. Thank you. Nikolai Arsenievich, what is your opinion? I'm for awarding. The work is good, and the degree applicant corresponds to the requirements. Thank you. Andrei Alexeyevich, I'm for awarding the degree of candidate of physics and mathematics. Pagos Aganesovich, I'm for awarding the degree of candidate of physics and mathematics. Thank you very much. And me as the chairman, I'm all for awarding the degree. I support other speakers. Thus, we all voted for awarding to Omar the degree of physics and mathematics. Omar is smiling. I understand this is good news, but now we have to finish the formal part and his final word. I have to hold on. First, I have to announce that 6 council members voted for awarding the degree. No one voted against, no one abstained. So the decision to award to Kotb Omar degree of candidate of physics and mathematics academic specialization has been made. And at that, because of that, I have to ask some formal questions. If council members have any comments regarding the procedure of today's session, I have to hear answers of all the council members. I have no comments. Thank you very much. I have no comments. Thank you. Thanks to our chairman. I have no comments. Thank you. Thank you, dear colleagues. I have no comments. Since there are no comments, let us give the floor to Omar for his closing remarks. Omar, the floor is yours. Thank you very much, but please don't take too much time. I'm very grateful to you and all the council members. And I don't know how I can thank my academic advisors, to Viktor Fyodorovich and Sofia Vladimirovna. They have always helped me. They gave me positive energy. All my colleagues at the Department of Polymer Physics, I am very grateful to you, and I hope that I will be very happy if we stay in touch with you. And also, I thank my teacher, Irina Vasilyevna, the first medical university named after Pavlov, who taught me Russian, and I can speak Russian. And thank you, my friends. Thanks to my friends who have been watching this, and my family. Thank you very much, everybody. Thank you very much. Thank you, Omar. So, on behalf of the Dissertation Council, we congratulate you. We all congratulate you with well conducted procedure. I think all the council members agree with me. Once again, please accept our sincere congratulations. And at that, I declare our session closed. I thank everybody for participation. Please stop the online broadcasting.